Greetings! Welcome to this new video about Supermesh analysis. Solve the problem number 3. Let's consider this network consisting of 4 resistors labeled R1 through R4 as well as 2 voltage sources V1 and V2 and 2 current sources IA and IB. The question now is to calculate the dissipated power in the R2 resistors. Let's move on to the solution. First, let's begin by defining the number of meshes in this network. It's evident that there are 4 meshes. This is mesh number 1, mesh number 2, mesh number 3, and mesh number 4. Now let's proceed to assign the mesh currents in this network. And I will consider I1 is the current in mesh 1, I2 is the current in mesh 2, I3 is the current in mesh 3 and I4 is the current in mesh 4. We can see here that all the currents are chosen in the clockwise direction. After we finish the assignment of the mesh currents, we need to remove the branch containing the current source IA. Then we obtain our super mesh. By applying KVL in the super mesh, we can write negative V2 plus R1 I2 minus I1 plus R2 I2 plus R4 I2 minus I4 plus R3 I3 minus I4 is equal to 0. By replacing the resistors and the voltage with their numerical values, we obtain negative 2 plus 3I2 minus I1 plus I2 plus 2I2 minus I4 plus I3 minus I4 is equal to 0. If we continue simplifying this equation, we obtain negative 2 plus 6I2 minus 3I1 plus I3 minus 3I4 is equal to 0. And I will call this equation number 1. Let's move on now to mesh 1. By applying KVL in mesh 1, we can write negative V1 plus R1 I1 minus I2 plus V2 is equal to 0. By replacing the resistor and the voltage with their numerical values, we obtain negative 5 plus 3I1 minus I2 plus 2 is equal to 0. If we continue simplifying this equation, we have I1 minus I2 is equal to 1. That means I1 is equal to 1 plus I2, and I will call this equation number 2. Let's move on now to mesh 2. By applying KVL in mesh 2, or we don't need to apply KVL in mesh 2 because we don't know the voltage across this current source, but we know that I4 is equal to negative IB is equal to negative 2. That means I4 is equal to negative 2, and I will call this equation number 3. We know we have now 3 equations but 4 unknowns. So we still only require 1 equation to solve this problem. In order to get this equation, let's focus on the current source IA. In IA we can write IA is equal to I3 minus I2. That means I3 minus I2 is equal to 1. That means I3 is equal to 1 plus I2, and I call this equation number 4. After we finish applying the supermesh analysis, we obtain 4 equations with 4 unknowns. By substituting equation 2, 3, and 4 in equation 1, we obtain or we derive only 1 equation in terms of I2, negative 2 plus 6IA minus 3 multiplying 1 plus I2 plus 1 plus I2 plus 6 is equal to 0. If we continue simplifying this equation, we obtain 4I2 plus 2 is equal to 0. That means I2 is equal to negative 2 over 4 is equal to negative 500 milliamps. After we finish calculation, we already found the current I2 through the resistor R2, then we can deduce or we can calculate the dissipated power in the resistor R2 is equal to R2 I2 square is equal to 1 multiplying by 0.5 square, we get 250 milliwatt. After completing the calculation, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is the circuit done by SPICE simulator. We have our voltage sources V1, V2, the current source IB and IA. In order to measure the dissipated power in the resistor R2, we connect the voltmeter here. Let's move on to analysis. This say analysis, calculate nodal voltages. We can see here that the dissipated power in the resistor R2 is equal to 250 milliwatts. Is the same value we have obtained by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. Have a nice time and bye bye.